So we're all using AI pretty much every day now, right? But how does it actually work? In this explainer, we're going to peel back the curtain, get past all the talk about magic, and dig into the real engineering, the core stuff that actually powers these incredible systems.
And this quote right here, man, it just hits the nail on the head. Even the brilliant engineers building the next wave of AI products are often using tools, APIs, that they don't fully control or even totally understand. And that creates some serious hidden risks. Our goal today is to give you that full picture, so you can see them too.
Okay, so where do we even start? Well, before an AI can do anything for us, it first has to understand our world. How in the world does it take our words, our documents, our big ideas, and turn them into something a computer can actually work with? It all starts with this concept called embeddings. To put it simply, an embedding is just a way to translate data, could be text, an image, you name it, into a long list of numbers. We call that a vector. But it's not random. That specific list of numbers captures the actual meaning of the data. So something like write a report and draft a summary become two distinct but closely related points in a mathematical space.
The best way to picture it is like a giant multidimensional map. Every single piece of information you can think of, a task, an email, a picture, gets plotted as a single point on this map. And here's the magic. The closer 2 points are on that map, the more similar they are in meaning. This one simple idea, it's the foundation for literally everything that comes next.
So, with that foundation of embeddings in place, we can now start to build the rest of the AI stack. Let's walk through the 5 core components that you're going to find in pretty much any modern AI application out there today.
First up, where do we put all of these embeddings? Where do they live? That's the job of a vector database. If you think of embeddings as individual memories, the vector database is the AI's long-term memory system. It's designed specifically to store these numerical vectors and search for them based on that closeness or similarity we just talked about.
And hey, this isn't just some abstract theory. It's a huge, rapidly growing industry. You've got major players out there like Pinecone, Weaviate, and a bunch of others, all building the infrastructure to handle billions and billions of these vectors at lightning speed. This is the tech that makes your AI assistant feel like it just knows you and remembers exactly what you need right when you need it.
Okay, so our AI has a memory. That's great, but memory alone isn't enough, right? It needs to be able to do things. That's where agent orchestration comes in. This is the logic loop, the thought process that lets an AI understand a request, figure out the steps it needs to take, and then actually use tools, like sending an email or checking a calendar, to get the job done.
Let's walk through it. Say you ask it to summarize my tasks and email my team. The agent first has to understand what you want. Then, it retrieves the relevant tasks from its memory in that vector database. Next, it reasons. It plans out the steps. Then it acts by using a tool, maybe calling an email API. It can even check its work and adjust if it needs to. This whole perceive, reason, act loop is what makes an AI a true assistant, not just another chatbot.
Now, let's talk about a huge problem with large language models. They can just make things up. You've probably heard this called hallucination. Retrieval Augmented Generation, or just RAG, is the solution. It forces the AI to base its answers on specific info it pulls from a trusted source, like, say, your company's private documents stored in a vector database.
And the difference is, well, it's night and day. Without RAG, the model is just going off its old, generic training data. It might just invent an answer. But with RAG, it retrieves the latest information from your data, which makes its response accurate and grounded in actual reality. This is what makes AI trustworthy enough for real business use.
So the final piece of the puzzle is all about connection. An AI agent is really only as useful as the tools it can connect to. The Model Context Protocol, or MCP, is this new emerging standard that's trying to solve this exact problem. The goal is to create a universal way for AIs to plug into any tool, any database, any calendar without needing a custom-built integration for every single one. The best way to think of it is like USB-C for AI. Remember that junk drawer full of a million different proprietary chargers? USB-C replaced that mess. Well, MCP wants to be that single standard connector for AI. It would let any agent talk to any tool, which is huge for preventing companies from getting locked into one ecosystem.
So, we've built our modern AI stack. We've got embeddings, vector databases, agents, RAG, and MCP. It sounds perfect, but This system creates a new, massive, strategic problem that most people just don't think about.
Here's the problem. For most teams, every single one of these core components is controlled by a different company. Your embeddings might get created by one API. Your vector database runs on another company's cloud. And your main large language model comes from a third. You are completely dependent on a whole chain of external providers you have absolutely no control over.
And that leads to the really critical question, doesn't it? What happens when one of those services has an outage? The answer is painfully simple. Your product goes down right along with it. You have zero control, zero redundancy, nothing.
In response to this exact fragility, we're seeing a growing number of engineering teams decide to take back control by bringing their AI infrastructure in-house.
Now look, this is a big decision with some very clear trade-offs. Using cloud APIs is easy to get started with, but you sacrifice all control, you send your data to third parties, and you're totally dependent on their uptime. Self-hosting gives you full control, it keeps your data private, and it lets you design for resilience. But yeah, it takes more upfront engineering work.
But self-hosting creates a brand new challenge that nobody ever seems to mention in those pretty architecture diagrams. Your amazing private AI model is now locked away inside your company's network. So how do your employees or your other applications access it securely from the outside world?
The modern solution is something called a zero-trust approach. Forget about those wide-open VPNs. Here, access is granted on a case-by-case basis. First, a user has to prove who they are. Then, a policy grants them access only to the specific model API they need. A secure encrypted tunnel is created just for that one connection. The request goes directly to the model and absolutely nowhere else. It is precise, it's audited, and it's secure.
So as we wrap up here, you can see it all comes back to this one central theme: control. Understanding these components isn't just about passing a test. It's about making smart, informed decisions about the systems you build and the systems you rely on every day.
So let's do a super quick recap of the 5 building blocks. We start with embeddings to understand meaning. We store them in vector databases to create a memory. We use agent orchestration to take action. We ground it all in reality with RAG. And we connect it to the world with MCP. Those 5 pieces, that's the architecture of modern AI.
And that brings us to the most important takeaway of all. Modern AI isn't magic, it's infrastructure. And just like any other critical infrastructure, it demands a plan. A plan for resilience, a plan for ownership, and a plan for security. So the question you need to ask isn't just, what can this AI do, but how does it actually work, who truly controls it, and what happens when it fails?
Thank you. Share and subscribe to Learn AI for more AI insights.